Let's talk about forward rates today and how to calculate them. So the way we calculate forward rates is we need a spot rate curve. And so a spot rate curve is a yield curve or a set of interest rates based on maturities that have zero coupons. So these are pure discount notes or bonds, if you want to think of them in that terms. So we go from 4% all the way to 6.5% on the 5-year note. So it's an upward sloping yield curve, as you can see here. And what we're going to find is that the expectations theory of the yield curve states that yields to maturity, which are what we see here, these are different yields to maturity, they are determined solely by expectations of future yield. So this is the expectations theory. It's not the only theory of why the yield curve is shaped the way it is, but it's the one we're focused on today and helps us calculate forward rates. So how are we going to go about doing this? Well, let's keep it simple. Let's say I wanted to invest money for 2 years. Well, I have two options for doing that. Number one is I could just lock it in today and invest in a 2-year maturity note for 2 years. So, we'll pull up those rates again and see what that rate was, but that was 4.8%. Or the option number two is I can invest in a 1-year note today and then reinvest at the 1-year note a year from today at whatever interest rate exists at that time. Now, our estimate of that note rate is going to be the forward rate. That's what our estimate is, and we're going to show you how to calculate that. F12 is the forward rate between years 1 and 2. All right, so this is what we're going to calculate. We're going to calculate that future rate that we think is going to exist a year from today based on this yield curve shape right here. I can invest for 2 years at the 2-year note. It's going to be compounded. That's why I raise it to the second power. So I'm going to get that rate of 4.8% twice, year 1 and year 2. Or I could get the 1-year rate and then reinvest those proceeds at the 1-year rate that exists 1 year from today. The forward rate is what our estimate's going to be for that interest rate. So I'm going to equate these two, and we're going to solve for F1, F12. That's going to be our forward rate calculation. So just plugging in the numbers here, 1 plus 4.8% squared, that's what we could guarantee ourselves today by investing in that 2-year note. Or we can invest in the 1-year note today, get 1.04, or roll it in and then roll it into whatever rate that is in the future. We're going to solve for F12. So rearranging the terms here a little bit, we get this equation. So we just divide both sides by 1.04. And then we do this math here. We get 1 plus the forward rate is simply going to equal 1.0561. So now all we have to do is subtract 1 from both sides, and we get the forward rate itself. It's 5.61%. So let's think about 5.61% here. This can also be thought of as the break-even rate. So two options. I can either go 4.8% for 2 years, or I can get 4% and then hopefully get 5.61% that second year. If I do that, that would give me the same money. Either way, I'm going to earn the same amount of return. So that can be thought of as a break-even rate, but that is the forward rate. The forward rate is the break-even interest rate that would equate these two. Okay? So you could do it between any years here. So let's do it between years 2 and 3. That may seem a little bit more complicated, but it's pretty much the same math, okay, with a little nuance here. So let's ask the question, what is the forward rate between years 2 and 3? Well, in this case, the first option is let's just lock in. What we can just lock in that 3-year note today, invest in a 3-year maturity note for 3 years, or we could invest in a 2-year maturity note and just kind of hope that that 1-year note that's going to exist at that time is going to be high enough. So I'm going to invest in the 2-year note today and then reinvest the proceeds at the 1-year note that exists at that time. And that's the F23. That's the forward rate that exists between years 2 and 3. So in this case, this is what I'm calculating, that 1-year rate that's going to exist between year 2 and 3. So here's how I express that mathematically. And this time, you can see I'm raising it to the third power. And that's because I'm getting that 3-year rate for 3 years. Okay? Or I can get this one, the 4.8% yield for 2 years, and then roll that in to the 1-year note. Okay, so just filling in the terms here. I put in 5.5%, that's my 3-year, and I put in 4.8%, that's my 2-year note rate. And then I'm going to solve for F23. So just rearranging the terms here, I divide each side by 1.048 squared, and I get this expression, and then I get 1 plus the forward rate is simply equal to 1.0691. Now all I have to do is subtract 1 from both sides, and I get 6.91%. So using this yield curve here, this spot yield curve, I was able to calculate 2 forward rates. If you recall, the first forward rate I calculated was between these two numbers. It was 5.61, and then the next one was 6.91%. So we're going from a spot 1-year rate of 4% today to an expectation that that spot rate is going to rise to 5.61% here, and it's going to rise to 6.91% here. So pretty significant increase in 1-year interest rates based on the expectation theory that yields to maturity are solely determined by the expectations of future yields. This is how you calculate forward rates. Hopefully that's simple enough for you. Practice a few before you have to take a test. And remember to subscribe to this channel, because this is where I make finance fun for students. Thank you.